morning, everyone. Today's topic are electrical energy, and the subject name is your power generation process. So, in this lecture, we are going to discuss about the different kind of electrical energy and what is how it is generated, or what is the procedure, how it is transmitted from generating station to transmission station, and then how can it utilize and what kind of components it used for this process. So this is a very wide subject, but in this lecture we will try to cover all the topics in brief, and in other lectures we will discuss it in detail. So learning objective of this lecture is that to understand the concept of power generation process, which include your transmission distribution, and the learning outcome that after this lecture I'm expecting from students, that student will be able to understand the concept of this power generation process, and it includes three types of methods. One is generation, transmission, and distribution. So let's start with this topic. What is power generation? So power generation means that the generation of electricity in technical terms, and the procedure which is followed, or the place where electricity is generated, that is called your generating station. After that, the electricity which is transferred from one place to another place, that is your transmission. And the third one is your distribution. So it consists of almost all electrical equipment, and they are placed at different locations. Depends on requirement, and all of them working together for the purpose of supplying electrical energy to consumer on economical basis. So main components are generation, transmission, and distribution. So what are the advantages of electrical energy? First, we have to understand that what are the advantages of electrical energy. So electrical energy is efficiency is low, reliability is high, and this is economical, easy to control, and no atmospheric pollution. And there are two type of generation. One is your conventional type, and another one is your non-conventional type. So, let's talk about the types of generation. So, one is your conventional type. In conventional type, we use thermal power plants, hydropower plants, steam power plant, nuclear power plant, diesel power plant, and gas power plant. So, bulk power generation in terms of megawatt and kilowatt generate high voltages. Installation cost is more and running cost is less. Synchronous generation are used, and transmission of power for long distances and then connected to distribution system. And let's talk about your non-conventional type. Non-conventional, for example, your solar, wind, tidal, biomass, geothermal, etc. So generation in terms of kilowatt and volts generate low voltages. Installation cost is less and running cost is more. Asynchronous generators are used, for example, induction generator for this purpose, and for conventional type, in conventional type we use synchronous generator, and in non-conventional type we use induction generator. So no question of transmission of power, and only connected to distribution of power. So first is your thermal power plant. So thermal power plant operate on the principle of Rankine thermodynamic cycle. So you can see in the diagram, thermal means that you are using heat or thermal energy of coal. By using coal as a fuel in this thermal power plant, what we do, we burn the coal, and the water is heated. After heating the water, water is converted into steam. That steam is used to rotate the turbine, and turbine is directly connected to your generator. So when turbine is rotated, the generator is also rotated. So generator convert the mechanical energy into the electrical energy. So first we are converting thermal energy into the mechanical energy, and mechanical energy is converted into the electrical energy. So This is the boiler drum, and its diameter is 168 kilogram per centimeter square, which is very large. The temperature of this is 320 degrees centigrade. Main steam, that is your diameter is 150 kilogram per centimeter square. The temperature of this steam is 540 degrees centigrade, which is very high. Then this is reheated steam. That is your 35 kilogram per centimeter square, 540 degrees centigrade. And the red line shows the main system. Purplish shows that reheated system, and dotted line shows that the flat steam. So this is your main steam, and this is your reheated. So main steam, you can see that is your high pressure valve, and it is going into this HPT and IPT. Then this is going into LPT. Then it is going to the generator. So air and cold is for over this boiler. There are superheater and reheaters. So what it do? It no heat it the water. Then water is converted into the steam. So this is your deaerator, BFP, HP heating, feed water, LP heaters. In details, we will discuss each and every part. So these are the basic diagram of your thermal power station. Now, what is your thermal efficiency? The ratio of heat equivalent of mechanical energy transmitted to the turbine shaft of the heat of combustion of coal is known as thermal efficiency of steam power station. And thermal efficiency eta is equal to heat equivalent of mechanical energy transmitted to turbine shaft upon heat of coal combustion. And the overall efficiency, the ratio of heat equivalent of electrical output to the heat of combustion of coal is known as overall efficiency of steam power station. So overall efficiency eta is equal to heat equivalent of electrical output upon heat of combustion of coal. So overall efficiency is equal to thermal efficiency into electrical efficiency, and efficiency meter is equal to output power upon input power. For example, we can take an example by which we can solve this problem. So the example is given that mechanical energy supplied to a DC generator at the ratio of 4,200 joule per second. The generator delivers 32.2 ampere at 120 volt. So what is the percentage efficiency of the generator, and how much energy is lost per minute of operation? So one is your input power. So input power is your 4,200 joule per second. If you want to convert this joule into the watt, so you will get 4,200 watt. And output power P naught is equal to EI, that is equal to 120 into 32.2 is equal to 3,864 watt. And the efficiency meter is equal to P naught upon Pi into 100. So you can calculate the efficiency by this formula, and you will get that is 92%. And the power lost PL is equal to PI minus P naught, that is 4,200 minus 3,864, 336 watt. And energy lost per minute of operation. So PL into T is equal to 336 into 60. That is your 20,162. So efficiency is always less than 100% or 1. In other words, every system is less than 100% efficient. So for this example, the efficiency of this power system is around 92%. Now let's come to the next example. Example number 2. So a steam power station spent rupees 30 lakhs per annum for coal used in the station. The coal has a calorific value of 5,000 kilocalorie per kilogram of cost rupees 300 per ton. If the station has thermal efficiency of 33% and electrical efficiency of 90%, find the average load on the station. So overall efficiency is equal to 0.33 into 0.9. The thermal efficiency is multiplied by the electrical efficiency. So overall efficiency will be there. And the coal use per annum, so the rupees uh, for coal is even 30 lakh per annum, and uh, cost of calorific value and cost per ton is 300 per ton. So you can find out that how how much coal you require in terms of ton. So you will get 10 to the power 4 tons is equal to 10 to the power 7 kilogram. So heat of combustion coal used per annum in calorific value, that is equal to 10 to the power 7 into 5,000. 5 into 10 to the power 10 kilocalorie. So heat output you will get, that is your meter overall into heat of combustion, and you will get 0.57 into 5 into 10 to the power 10, 1485 into 10 to the power 7 kilocalorie. So units generated per annum, that is equal to 1485 into 10 to the power 7 upon 860 kilowatt hour. So average load on station, that is units generated per annum upon hours in a year. So 1485 into 10 to the power 7 upon 860 into 8760, you will get 1917 kilowatt. Now let's come to the next plant, that is your hydropower plant. So what is hydropower plant? In hydropower plant, we convert water, we use water to generate electricity. So a generating station which utilizes the potential energy of water at a higher level for the generation of electrical energy is known as hydroelectric power station. So you can see in this diagram that it's your reservoir where you can reserve the water. This is your intake pan stove in which your water comes through with pressure and it goes to the turbine and turbine rotates. So kinetic energy of water is converting into the mechanical. And by using the mechanical energy, by using the turbine, the mechanical energy is transferred to the generator, and this generator converts mechanical energy into the electricity. If there is a powerhouse, by transmission lines, the power can be transmitted. So let's do some example which is related to your hydropower plant. So the first example is water for hydroelectric station is obtained from the reservoir. So water for a hydroelectric station is obtained from a reservoir with a head of 100 meters. Calculate the electrical energy generated per hour per cubic meter of water if the hydraulic efficiency be 0.86 and the electrical efficiency is 0.9. So let's solve this numerical. So you can see that water had H is equal to 100 meter and discharge speed is equal to 1 meter cube per second. Meter overall efficiency, that is 0.86 into 0. So you will get 0.79. And water available per second, W is equal to 2 into 1000 into 9.81. And power produced, W into H into N, that is equal to 910. W is already given, water available. And the H, that is your water head. And it is your overall efficiency. So you will get 775 kilo. So energy generated per hour is equal to 775 into 1. That is 775 kilowatt hour. Good morning, all. In this lecture, we are going to discuss about electricity bills. So, we pay electricity bills every month, and what is the procedure to decide that how much we have to pay for one unit. So, in this lecture, we will discuss about that. There are different type of tariffs on which the electricity bills are based, and there are different calculations which is done to pay the electricity bills. So, this is the subject power generation electronics. What are the learning objective? The learning objective of this uh, lecture is to introduce the students about different types of tariff and learning outcome that student will be able to understand different types of tariff. So what is the first we will discuss about the definition. So the rate at which, what is the definition of tariff? Okay. So in technical language, the charges we pay for electricity is called tariff, and there are different kind of tariffs, and there are different calculations which on which the tariff rates are based. So first we have to understand that what is the definition of tariff. So the rate at which electricity energy is supplied to a consumer is known as tariff. And although tariffs should include the total cost of producing and supplying electrical energy plus the profit, yet it cannot be the same for all type of consumers. Okay, it will depend upon that how much electricity is consumer is using, which kind of phases he is using. Suppose he is using single phase or three phase. It, if he has only resistive load or resistive or inductive load and RLC load, motor load, and what kind of consumer is it is industrial or you know commercial. So it will depend upon the consumer. So although tariff should include the total cost of producing and supplying electrical energy plus the profit, yet it cannot be the same for all types of consumer. So what are the objective? Recovery of cost of producing electrical energy at the power station and recovery of cost on the capital investment in transmission and distribution system and recovery of cost of operation and maintenance of supply of electrical energy. For example, metering equipment, billing, etc. So a suitable profit on the capital investment is done. Now, what are the factors which is affecting the tariff? So there are the following factors that are taken into accounts to decide the electricity tariff. One is your types of load, which kind of load you are using, maximum demand, the time at which load is required, the power factor of load, the amount of energy used. So these are the different factors which is used when you decide that how much charges you have to pay for your electricity bills. So desirable characteristic of a tariff. So the tariff must have the following desirable characteristics: proper return, fairness, simplicity, reasonable profit, attractive, and these are the different types of tariff. One is your simple tariff, flat rate tariff, block rate tariff, two-part tariff, maximum demand tariff, and the power factor tariff, three-part tariff. So these are the different types of tariff. And in the in detail, we will discuss all kind of tariff. That what is your simple tariff? Why this is called simple tariff? What are the flat rate tariff? Block rate tariff, two-part tariff, maximum demand tariff, the tariff which is depend upon power factor, that is your power factor tariff, three-part tariff. This tariff depend on the three parts. One may be your active power, reactive power, power factor. So there are n number of factors on which your tariff is depend. So first we will understand that what is your simple tariff and what is your flat rate tariff. So let's discuss about your simple tariff. So when there is a fixed rate per unit of energy is consumed, okay? So the energy which you are consuming, that is almost fixed, okay? So that it can be consumed in a uniform way. So in this type of tariff, the price charged per unit is constant. So it does not vary with increase or decrease in the number of units consumed. So the consumption of electrical energy at the consumer's terminal is recorded by means of an energy meter. So what are the advantages of this tariff? Actually, this tariff is very simple and it can be easily calculated, it can be easily applied, easily understandable and easy to apply. Each consumer has to pay according to his utilization. So, what are the disadvantages? Disadvantages of this tariff is there is no discrimination according to the different types of consumers. The cost per unit is higher. There are no incentives and makes the consumer use more electricity. If a consumer does not consume any electricity in a particular month, the supplier cannot charge any money even though the connections provided to the consumer has its own cost. So these are the disadvantages. Now, what are the application of this simple type of tariff? So the simple application of the this tariff is generally applied to the tube wells used for irrigation purposes. So these are the simple application which is applied for calculating this kind of tariff. Now, flat rate tariff. Let's discuss about the flat rate tariff. So in this tariff, different types of consumers are changed at different rates of cost per unit of electrical energy consumed. So different consumers are grouped under different categories and each category is charged money at fixed rates similar to simple tariff. So the different rates are decided according to the consumers. So their load and load factors. So flat rate tariff is dependent upon different factors. Uh, what are the advantages? So more fair to different consumers and simple calculation. But what are the disadvantages? So a particular consumer is charged at a particular rate, but there are no incentive for the consumer. Since different rates are decided according to different loads, and separate meters need to be installed for different loads such as light loads, power loads, etc. So this makes the whole arrangement complicated and expensive. So all the consumers in a particular category are charged at the same rates. However, it is fairer if the consumers that utilize more energy to be charged at a lower fixed rates. So what is block rate tariff? In this tariff, the first block of the energy consumed is charged at a given rate, and the succeeding blocks of energy are charged at progressively reduced or increased rates. So the rate per unit in each block is fixed, and energy consumption is divided into fixed per unit blocks. The price per unit in the first block is the highest. So, according to the provider's necessities and priorities, accordingly, it is progressively reduced for the succeeding blocks of energy. For example, the first 50 units, one block, two block, and three block. So this is divided into three parts. So in the first block, it may be charged at 3 rupees per unit, and the next 30 units, it may be charged as 250 rupees, 2 rupees 50 paisa, and per unit. And for the next 30 unit, it is charged like 2 rupees per unit. So, advantages only one energy meter is required. Incentives are provided for the consumers due to reduced rates. So, hence, consumers use more energy. This improves load factor and reduced cost of production. Applications generally apply to domestic consumers and small commercial consumers. Next is your two-part tariff. So in two-part tariff, when the rate of electrical energy is charged on the basis of maximum demand of the consumer and the units consumed, it is called a two-part tariff. The total cost charged to the consumers consists of two components, fixed charge and running charges. The fixed charges will depend upon maximum demand of the consumer and the running charge will depend upon the energy consumed. So this is all about your two-part tariff, and it can be expressed as total cost is equal to A kilowatt plus B kilowatt hour rupees, where A is charge per kilowatt of maximum demand, constant, which when multiplied with maximum demand gives the total fixed cost, and B charges per kilowatt of energy consumed. Good morning, everyone. In this lecture, we are going to discuss about power factor. What is a power factor and what is power factor correction? So, power factor is very important part of power system engineering or electrical engineering. Actually, the cost of electricity is dependent upon power factor. The quality of electricity is also dependent upon the power factor. So, it is a very important topic. In this lecture, we will discuss about the power factor and how a power factor can be controlled and how it affects our power generation process or power system engineering. So these are the learning objective. So learning objective that is define power factor, define unity, leading and lagging power factors, define power factor correction and unity power factor correction, calculate the inductor or capacitor value required to correct AC series parallel networks to the desired apparent power, compare currents, voltages and power in AC series parallel networks before and after power factor correction. So what is power factor? Power factor is tells us what portion of the apparent power is actually real power. So power factor is a ratio which is given by Fp is equal to cos theta, which is equal to P upon V RMS into I RMS, and power factor is equal to P upon S. So where P is your active power, and which is divided by voltage into current. So you can also write P is equal to VI cos theta on cos phi, where phi is your power factor angle and cos phi is your power factor. So power factor tells us what portion of the apparent power is real power. So power factor is expressed as a number between 0 to 1. So the minimum value of power factor is 0 and the maximum value is your 1. So you can say the power factor is as a percent from 0% to 100%. So the closer to 1.0 the power factor gets, the more resistive. The closer to 0.0 the power factor gets and more reactive. If the power factor is closer to 0, then the power factor is more reactive. So the power factor angle phi must be 0. The voltage and current, the angle between voltage and current must be 0 in the ideal case. So cos 0 becomes is equal to 1. Now power factor from the power triangle, it can be seen that Fp is equal to P by S or cos theta. So power factor angle is thus given theta is equal to cos inverse P by S. For a pure resistance, theta is equal to 0 degree. For a pure inductance, theta is equal to 90 degree. For a pure capacitance, theta is equal to minus 90. So if you draw, active and apparent power in a vector diagram, so you will get this kind of vector diagram. And on the x-axis, you can take real power. On y-axis, you can take reactive power, and the vector sum of these power is your apparent power. So from the equation you can write Fp is equal to P by S is equal to cos theta. So power factor angle is thus given. Theta is equal to cos inverse P by X. So for a pure resistance, theta is equal to 0 degree. For a pure inductance, theta is equal to 90 degree. For a pure capacitance, theta is equal to minus 90. Now, power factor leading or lagging. So, how can you differentiate a power factor which is your leading or lagging? So, the term leading and lagging are defined in reference to the current through the load. So, if the current leads the voltage across the load, then the load has a leading power factor. If the current lags the voltage across the load, then the load has a lagging power factor. So, what is your leading and lagging power factor? You can see here. Fp is your power factor, which is equal to cos theta. Fp is equal to cos 40 minus 20. And Fp is equal to cos 16, that is equal to 0.5. So if you see that there is a motor, its voltage and current V is equal to 120 sine omega t plus 80 degree, and I is equal to 5 sine omega t plus 30 degree. So Fp is equal to cos theta and Fp is equal to cos 80 degree minus 30 degree. And cos 50 degree is equal to 0.64 like. So what is your unity power factor? Fp is equal to 1. Unity power factor implies that all of our loads apparent power is real power Fp is equal to 1, then theta is equal to 0 degree. It could be also be said that the load looks purely resistive. So in resistive load, there is a voltage waveform which is same with current, and there is no angle between voltage and current. So it could be also that the load looks purely resistive and the load current and voltage are in phase. Lagging power factor theta is always greater than 0 degree. So the load current lags over load voltage implies that the load looks inductive. Now, leading power factor, theta is always less than 0. So the load current leads load voltage implies that the load looks capacitive. Sample problems. First, we will discuss about some examples by which you will be able to understand that what is your power. So determine PQ, S, and delta FP for the circuit. So draw the power triangle. Is it leading or lagging power factor? Is the circuit inductive or capacitive? So you can see that this is the solution by which you can easily understand that what is your power factor.